All right, so we're talking about specific immunity. We talked last time we were together, and I'm giving you the warning, we may not meet again tomorrow, right? I'm sure you've seen the weather. It's not supposed to be very nice, so a delay is very, very possible tomorrow. So again, just because we don't have class doesn't mean you don't spend time with A&P, right? Because the test is Friday, okay? So we're talking about this third line of defense. First line being things like your skin, keeping stuff out, some of the innate defenses. And then the second line being some of the other, like the macrophages, the NK cells that are actually in your body doing some killing. The third line is this immunity piece, and that's just the specific response to a specific antigen. I see, I recognize you are bad, I kill you. We cool? Oops, shocking the board here. Antigens, of course, are just the little molecules that tell your body, hey, this is foreign. And it's kind of cool to think about your body doing like this cataloging of its own cells, which makes sense, right? I need to know what's mine before I know when to attack something else, right? And so these antigens are just these molecules that will make this immune response. Where do they come from, these lymphocytes? Two of them, right? T cells and B cells, or T lymphocytes and B lymphocytes. The T cells come from where? The thymus. They all start out in the blood marrow, but they go mature in the thymus, part of that lymphatic system. Whereas the B cells, where do they mature at? In the marrow. So they basically, the same place they're created, that's where they mature. The majority of them are the T lymphocytes. And both of these guys hang out in the lymphatic organs, right? In the spleen, in the lymph nodes. We cool? Because again, that's where the fluid's coming through. They're also in the bloodstream because, of course, lymph and blood tie in nicely together. Oops, stay there, stay. So two types of immunity that we're dealing with here. We have the cell-mediated, and we have the humoral-mediated. And again, think of it as cells versus humors. Does anybody know what humors mean? Not like, ha, 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 that's funny. But a liquid. That's an old Latin word for liquids. The humors of the body, the fluids of the body. Okay? So we have the cells and we have the fluids. The T cells are involved in the cell-mediated immunity, and that's direct cell-to-cell contact. It's basically battle royale between the T cells and the invading viruses or bacteria, these kind of things. They secrete these things called cytokines or lymphokines. We'll talk more about these as we go. And they basically tell the cells, hey, this is a bad thing. We need to attack this thing. We'll get to more about those guys. The B cells, again, the humoral immunity, these guys are producing antibodies. Or if you want to sound all impressive, because everybody knows what an antibody is, you call it an immunoglobulin. And, oh, wow, you must be smart now. Oh, that's just an antibody? Oh, okay, same thing. Does that make sense? Immunoglobulins, antibodies are the same things. And the B cells are the guys who produce those. When they differentiate into a plasma cell, we'll talk more about this. When they change into a plasma cell, or when they produce a plasma cell that makes these antibodies, that's what then attacks the antigens. And again, we call that the humoral immune. So again, cell-mediated from the T cells, humoral-mediated, humoral immune response from the B cells. Let's get more details. So, the T cells basically need another cell, like a B cell or a macrophage, to first find the antigen. Remember, the antigen is the thing that tells it it's not from you, right? We'll make Eric again the bad thing here. Okay, so when that Eric virus is coming in, first, a macrophage or a B cell would have to ingest one of these Eric viruses and then literally put little pieces of him out on the outside of his cell. It's kind of weird. Think what Hank says in his video. Think of it like, you know, those warriors who would like kill somebody and then like keep their knuckle bone and make a necklace out of them. So you're like, oh yeah, look at, here's all the people I've killed, right? I'm impressive. That's basically what the cell is doing. It's saying, hey, look, I've killed this bacteria. I'm going to put this little piece out as a trophy. But it's not just a trophy. It's basically to tell the other cells, hey, I've killed this thing and I'm pretty sure it's bad. Am I right? And you'll find out that that's basically what the B cell does. It just like kills stuff and it's like, is this me or is this somebody else? And the T cell, the helper T cell, has to come and say, oh no, yeah, that's a bad thing. Let's fight against it. Okay? So the T cells, they need these antigen presenting cells that, again, cut off the little piece and they put it in this thing called the major histocompatibility complex, this protein on the outside that basically says, hey, no, this is a bad thing, right? And when that T cell comes and attaches onto that antigen and says, oh yeah, no, this is a bad thing, that activates the T cell. And it starts cloning itself, starts making more of itself. And it actually comes in a couple different varieties, these T cells. It also activates the B cells and says, hey, you need to start attacking this thing. This is a bad thing. And we need to make some antibodies. Yes? No, it's actually on the macrophage or on the B cell that has already eaten the Eric virus. It's on that antigen presenting cell is where that MHC is at. Sir?
So the T cells can't do anything until B cells go.
Right, something, either or a macrophage or some other piece of something has to first eat it and present that antigen to the T cell. That's correct. So I told you the T cells start producing different flavors of itself. There's basically three kinds. You have the helper T cells, which we'll talk about more when we mention about the B cells. The helper cells basically are the ones that, so again, Daisy is our B cell that's eaten this Eric virus. I'm sorry to keep picking on you guys, but you're right here, right? And Daisy is unsure whether Eric is a bad thing or not. Okay? She's a little immature, a little naive. She's not sure, right? So she basically says to the helper T cell, hey, is this a bad thing? Like, I'm showing you this piece of his, his knuckle bone that I've put on the outside. Is this bad? And the helper T cell says, oh yeah, no, that's bad. And it starts producing these cytokines that say, oh no, this is a bad thing. If you see Eric viruses, fight against it. Does that make sense? So the B cell can't actually work until it gets confirmation from the helper T cell. Sure, they're all just in the lymph and in the blood together. Absolutely. Yeah.
You said that the B cell can't fight it until the T cell tells it to.
Mm-hmm.
But the B cell already does.
Sure, but it doesn't know if, because again, it's finding things that it thinks are bad and it attacks. But it's not going to create this whole big response until the helper T cell says, no, yeah, that's bad. Does that make sense? If it finds antigens that it fits, like its receptors fit onto, it will attack them. But it may not promote this whole big, huge response. Right, because there's other pieces there. We'll talk about that in a second. The memory T cells and the memory B cells, they've already gone through that process. And they're basically like the old sages that go, oh, yeah, that Eric virus? No, yeah, let's attack him. And not have to go through this whole process. Let's just immediately attack him. You're correct. Oh, good. Yes, excellent. So again, helper T cells. The next is the cytotoxic T cells. The cytotoxic are the guys who actually do the fighting, right? So these are the cell-to-cell combat. These are the warrior T cells. We good? And they do it through a whole variety of methods. It's really quite brutal. They'll like cut little holes in the cell. They'll like surround it so it can't do other things. They're ruthless because they want to get rid of those Eric viruses, right? And then the last one, like we said, are the memory T cells. Like the question that Favor and that Joshua are asking, they help to remember that these viruses or these antigens are bad, so that the next time you get exposed, it's immediate. You are beyond my pay level. At the molecular level, what I'm assuming they do is they keep some sort of antigen very present on their outside, and that just tells them that, hey, no, this is a receptor for that antigen and it's bad, but I honestly can't answer you more than that.
Those cells can mess up sometimes, though, right? Because the cell is bad.
Sure, that would be called an autoimmune disease. So I'm assuming, and we'll get more to the autoimmune pieces, and there's a number of different theories as to why that happens. It could be that in that maturing process, they get switched, like they don't realize that that good cell, that what they think is a bad cell is actually a good cell. It can be that you have bacteria that are so similar that they think it's a good cell and it's really a bad cell. There's a number of different ways. Your textbook has actually a pretty decent piece on how that happens. I'm not too concerned about you guys being comfortable with that. Okay, let's keep going. So that was T cell, right? And again, that's cell to cell. The big difference between the T cell and B cells is that the B cells aren't actually doing the major attacking. Yes, they do the initial eating of some of the cells to see whether they're bad or not, and then get checked out by the helper T cells. Excuse me, but the main thing that the B cells do is what? What's their main response? To produce antibodies. They're producing these immunoglobulins, right? So again, that's what this is, all the stuff we've already talked about. Again, how the B cell becomes activated by a helper T cell saying, oh yeah, no, that's bad. Produce that. Produce those antibodies. And again, some of those B cells become what we call plasma cells. And these guys are what are making the antibodies. Hank said something on the order of it can produce over 1,000 of these little antibodies a second. Just blasting out these antibodies to try and kill this, again, invading Eric virus. And some of those B cells, just like the T cells, they become memory cells. So that they remember, oh yeah, that Eric virus, he's a bad guy. If I come into contact with him, I can produce the antibodies super fast to affect him. Are you with me, my friends? I'm kind of going past these pictures because I don't think they help too significantly. But the point is, here's our B cell that's been activated. It can produce either the plasma cell, which is actually making the antibodies, or it can make a memory cell. For the T cell, there was 3 pieces, right? It can produce the helper Ts. Excuse me. Are we good here, my friends? If you're following along with our study guide, we're basically up to here, right? There's a very nice table. I don't have it on the board, but on page 401, table 14.2 that I mentioned in your study guide, kind of gives you a nice little summary of how the T cell versus B cell, the cell-mediated versus the humoral-mediated immunity works. I would recommend that.
Or the things that you said that B and T cells produce, or can produce.
The Bs make the plasma cells that make the antibodies and the memories. The T cells become either the cytotoxic T cells that are actually killing things, the helper T cells that basically help the B cell understand, hey, this is a bad thing, and then the memory T cells that help store, that has 3 instead of 2. Yes? I'm sorry, I can't hear you. I'm deaf. Mm-hmm. I just basically want you to know where those are located. Again, the thymus up here, the spleen down here, just in general, so you have ideals. Yep. Okay, so let's talk about those antibodies. You may have noticed on your study guide, I didn't ask you to know all 5 types of, I'm okay if you don't know them, all 5 types of the antibodies or the immunoglobulins. But I do want you to understand the 3 ways that they react to the antigens. So you've got 5 major types. The IgG and IgA are the 2 most common. And the IgG is in the tissue fluids. They're defending against bacteria, viruses, cells, and it activates this complement, which we'll come back to that. It's another protein that's in the lymph and the blood. IgA, we get those mostly from other secretions. So this is how a mother transmits immunity to her baby, right? That's why breastfeeding is so important for babies to get, if possible, because you're actually getting some immunity from the mother to the baby to help that baby.
Will some babies be like unhealthy if they only have their mother?
So it's not that they're necessarily unhealthy, they just have less immunity because they're not getting, they can't put the immunity pieces into formula, only just through the breast milk. And there's actually even a special milk the very first time you feed called colostrum that's very high in these antibodies, these IgAs. That's a good question. That immunity is very short-lived. So could it, for a period of time, it could, I guess, I'm not sure. That's not a bad idea. There may be some difficulties with, because the body would recognize it as a totally different cell than its own, whereas the mother's is very similar to the baby's. So, like, we don't want the immune response to attack the IgAs. Does that make sense? So that may be an issue.
I don't know if you've ever heard of this, but whenever my mom finds someone breastfeeding and we get some milk and then we put it in
Yeah.
the eye, and is that why?
I would imagine so. You're correct. Yeah. Interesting. Did you have your hands up, Nels, or no? I thought you did. All right. Okay. Again, IgM, IgD, IgE, these are all the other pieces of the antibodies. The antibody actions, which I don't think, is there a slide? Oh, there is. Good, sorry. 3 ways the antibodies attack. One is direct attack, which is like it's just attacking. Okay, and there's multiple varieties of how that works. The second is it activates complement, which we'll talk about in a second. And the third way is it starts to make other changes in the area that prevent the spread to pathogens. Basically, it's activating your innate defenses, the inflammation, the fever, these kind of things. Does that make sense? So it's attacking straight up. It activates this complement system, which is actually another system in your body, another one of the kind of innate defenses against these bacteria. It's a protein in the blood that can do all of these different kinds of things, where it's actually killing the cell itself or allowing it to clump together or bringing other attacking agents to the cell. This is, again, all the roles of these antibodies. And again, the third one would be to actually attack directly. Sorry, right, I was going backwards there, but yes, stimulation of other areas, so that would be inflammation, fever, that kind of stuff. That was the third piece. Your textbook makes a big deal about the different kinds of immunity, which I'm not as important. You don't have to, the practical classifications is on page 402. I do want you to understand primary immune response versus secondary immune response. So let's talk about that. All we were discussing before is the primary immune response. This Eric virus has never come into your body, and your body doesn't know for sure if it's bad or not, right? So it has to go through this whole process of the B daisy cells coming in and attacking and displaying its fingers out on the outside, And then the helper Hannah T cells come and say, oh yeah, that's a bad one, attack it. And she produces the cytokines to get everybody else involved in attacking this. You with me? That's our primary immune response. It takes a number of days, on the order of even 5 to 10 days afterwards, from that initial attack of the Eric cell, for you to really get significant amounts of antibodies produced. Does that make sense? There's a delay in the response. And I'll get your questions in 1 second if I can. The secondary immune response comes after the body's already had this first response. And we have the memory B and T cells, right? So, that's the memory B Isabelli back here, right? And the memory T Josh, who's like, oh yeah, I remember that Eric virus. Yeah, he's no good. Let's attack him immediately. And so the B cells start spitting out the antibodies immediately to start attacking the Eric cell. It doesn't have to go through the whole process of, hey, is he bad? Is he good? No, it just attacks because it knows it's bad. That's our secondary immune response. And that's the whole point of vaccines, friends. The vaccine will give you that primary immune response. It will say, hey, here's a little bit of the Eric virus that we've either made him super weak or we've literally just broken him apart and putting pieces in, but still enough that your body recognizes the antigens. And you'll make that primary immune response. You'll make those memory T and B cells so that the next time he comes, you can actually attack and fight him off. Questions? No, I got it. Yes? No, actually, babies will be much faster. This process of, and I think it comes from the fact that the baby is being inundated with all these different antigens it doesn't recognize. And so the system just works really quick to identify, oh no, this is bad, and then quickly fight it. One of the craziest things as a parent, this will happen to you when you have kids. Your kid will be playing fine outside. They'll come in and they'll start running a fever. They'll look really sick for like 2 hours, and then they're back to normal and go out and run and play. They have just that quickly identified a virus, responded to it, attacked it, defeated it, and then moved on. It's craziness. You and I don't do that very often. You know what I mean? It takes us much more time for that. Sir?
You said there's like a delay the first time in like making the antibodies?
It just takes time for that whole process of the handshake between the helper T's and the B's and then actually making and producing.
So it's not the actual delay of making it.
Yeah, no, it's not like the body's saying, I'm going to wait. It just takes time to run through that whole process.
Would you, with the secondary immune response, would that, be quicker than the primary? Or, at the same time for recovering something like that?
No. Oh, I see what you're saying. No, you would think the sickness would last less. You would think it would be easier. Yeah, certainly. If you're talking about getting fully sick from it, not an immunization. I think it is your body trying to use its energy for other things, actually to fight this illness. I'm not sure that sickness in itself makes you drowsy. Certain medications certainly do. But you'll feel that fatigue, and it can be a symptom of the sickness. It's your body saying, I got to fight this. So stop exercising, stop doing all the other stuff that's taking energy. Let me fight this thing. Cool. We're doing well. Are we good? I've not overwhelmed you yet? I see a lot of good eyes still with me. It's a lot of stuff. This is what I'm saying. I don't care that you know these. The naturally acquired active immunity or artificially acquired. They're just saying this is what you get when you actually get exposed to the antigen. This artificially comes from vaccines. Artificially acquired passive is where literally, and Hank talked about this in his video, the Ebola virus, you all have heard of this, right? They used to think you could not possibly survive that. But then people did. So what they would do is they would literally take their blood and take out some of the antibodies for the Ebola virus and inject them in other medical workers so that they could get that passive immunity. They're getting immunity from somebody else to help their bodies fight these viruses so they could actually keep working. Does that make sense? I think it's very cool, actually. And that naturally acquired passive, that's, again, the mother passing along these antibodies in the breast milk to the baby. Again, I don't care if you know these, but I just wanted to make sure to point them out to you. Yes, ma'am? So again, the vaccine itself is trying to promote an immune response. It wants to start that cascade of processes to make the antibodies. Depending on the vaccine, it can actually get you partially sick. Rarely, if ever, do you get the full disease sickness, but it can promote an actual response that makes you feel sick or ill, or yeah, and that's okay. And again, the point is you want that to be controlled when and how much, rather than just having all these Eric viruses attack.
The vaccines, like, do that, which is good. Why are people, like, some people are really hurting?
So you want to know this? I was just debating with myself whether I was going to have this conversation because we're not going to get to the rest. We'll have to finish tomorrow. You've heard, I'm sure, right? All this conversation about vaccines being bad. It stems from one study. That's it. It was one study that was done by this British physician on a very small population. And when it came out, when they redid and re-looked at his material, it was faked. He literally made up the results. I'm not kidding you. The journal he published this in, of course, again, you all know how it works in the world of science. You do research, and then you publish it into what's called a peer-reviewed journal. You send in your thing. These experts are actually going through and saying, oh, change this, look at this. That journal who had published this initially, when this stuff came out, they retracted it. They said, no, this is no good. This is junk. And yet, it continues to be out there that, hey, this is not a good thing. You can find, again, you just search vaccines are bad or problems with vaccines. There's tons of stuff out there. Are there things about vaccines that they have to change that could be better? Sure, because there are things that are in them that you look and you're like, wait, why is that there? But the point is, the immunity you get from these is just invaluable. It's invaluable. Some folks would argue that this is the largest advance in human civilization, vaccines. That we aren't just decimated by these diseases, because there are places that are still. And when you have these groups of people who won't get vaccines, they cause problems for you. You know what I mean? Like, let's take the measles, for example. That was almost completely obliterated. There was like 1 or 2 cases a year for a number of years. And then you had these pockets of folks who didn't immunize, and so they would get sick. They'd get exposed to the virus, and they would get sick. And it just creates more and more problems. They were relying on what's called herd immunity. Well, if 99% of people have the vaccine, then they're going to keep me from getting sick. Well, that works until too many people don't get the vaccine. You know what I mean? So now, if you're allergic to that flu shot, they wouldn't recommend it. There are a number of different types that are what they use to grow it or what's in the vaccine can be different depending on the maker of the vaccine. So they may be able to find one that you have ingredients you aren't allergic to. The flu shot's difficult because there's like literally thousands of influenza viruses that cause the flu. There's not one. And so basically, the government folks have to decide months in advance what flu vaccine they're going to give you to go for what specific strains of viruses. They haven't yet been able to make one that covers them all. They're working on that, but they haven't been able to do that. So they guess. I mean, it's a good guess. It's logically based on what they see. But like this year's in particular has been not very effective because the virus that is mostly going around is a different strain than what the most of the vaccines are. Like it's too late because it takes time for them to actually make the vaccines and then get them out to folks. It's not like I can say, ooh, let's change because the Neha virus is here and not the Eric virus. It takes too long. By the time they actually did that, it's already past flu season. So they have to do that months in advance.
Wait, when is flu season?
Basically November through the end of spring. Yeah, winter time here in this country. Okay? So there's really only 2 more pieces left. We'll finish that. I've only got 4 slides. I've only got 3 minutes. So we'll talk a little more about these tomorrow, but let me quick pop them in here. Allergic reactions. Are you comfortable? Allergic reactions are simply your body, it's an excessive immune response to a certain type of allergen, a certain something that that gets into your body, like an antigen, but this is something that causes your body to way overreact. And mostly what we get are what we call delayed reaction allergy responses, which is like poison ivy, right? You rub this oil on your skin out in the woods, and within a day or so, you start developing this rash, right? It's the immediate reaction allergies that are a significant problem. These guys are ones where you have just this huge release of histamine from the mast cells, and the body just starts shutting down. You start having difficulty breathing. You have tightness in the throat. All of these things that can kill you. Anaphylactic shock is what they're talking about there. There are people in this room, I am sure, who have severe allergies to, let's say, bee stings or penicillin. These are the 2 of the biggest ones, right? And so they have to carry an EpiPen, an epinephrine pen, that basically helps to, it's literally injecting adrenaline into your system to help you fight against these anaphylactic shock symptoms, to keep you alive. No fun at all. No fun at all. The last piece I wanted to mention is about tissue rejection. Tissue rejection, when you have, let's say, a new liver or a new heart, you're putting in somebody else's cells, right? The immune system's whole job is to attack other people's cells, right? Or other things' cells, things that are not you. So they give what they call immunosuppressive drugs to basically tell your immune system, no, calm down. Don't fight this. What's the problem with that? Right. If other Eric viruses come in, you can't fight against them, right? Because you're too busy making sure it doesn't fight against your new heart that they just put in. Does that make sense? So again, they have lots of different ways they try and counteract that. Last but not least is autoimmunity, where basically your body cells, your immune system starts attacking its own cells. And again, there's a couple different reasons why they think this could happen, but the main point is that your body is attacking itself. In type 1 diabetes, it's attacking the cells in your pancreas that are making insulin. In rheumatoid arthritis, it's attacking the cells in your joints. Autoimmune, you are fighting yourself. More tomorrow. Adios.